right, so we are here. I'm actually done with 3.3, so I'm a day ahead. But again, we're not stopping. We're going ahead in case something goes wrong again and I have more internet problems or I get sick or whatnot. So it looks like I'm a day ahead. So I'll lecture for 3.4 for a while, and then we'll take our quiz. Okay, so our next exam isn't until the 9th of October, it looks like. So quiz here, quiz here. Looks like we actually have some buffer days. Again, buffer days don't mean holidays. I just put that in case, I get sick or something goes wrong. Right, so it looks like we're okay time-wise. Right, so I'm ready to start some of 3.4. And I gave you the basics from 3.4 at the end of class yesterday. So I'll do some problems, and after a while I'll stop and we'll do the quiz. Okay. All right, so make this disappear. Now the first problems involve the graph of some of these functions. So page 168. Okay, so how do you do stuff like 1 and 3? And again, I'll just do this quickly again for those of you that don't have the book and you're never getting it. So you can look at the video for the problems. So that's up to about 15. That's the rest of that. Okay. And then on the next page, and that's about it. And yes, you might say, well, you already did that. Yeah, I do a lot of redundancies. You probably noticed. In case you didn't get it the first time, I'll say it again. So I'm aiming for redundancy, or you missed the lecture or whatever. Okay, so let's do number 1. So 1, 3, and 5, they give you graphs. So they're asking for the domain, the range, and the vertical and horizontal asymptotes of the function. Okay, so vertical asymptotes, horizontal asymptotes. Okay, asymptote, there's spelling, I'm not sure if you can see it, A-S-Y-M-P-T-O-T-E. It's a line that the graph gets real close to, it approaches. Okay, so these rational functions look something like this sometimes. Okay, number 1, domain. Well, it looks like x is not allowed to be -1, but it's allowed to be anything else. So for number 1, the domain is all real numbers except for -1. Okay, I'm not sure if I can show you both at the same time. Yeah, kind of. Okay, so this graph and this answer. So the domain is all real numbers minus the set consisting of -1. B, range. Okay, well, y cannot be 0. Looks like the x-axis, which is y equals 0, is an asymptote, but y can be any other number. It can go down as much as you want and as high as you want. So the range is all real numbers minus the set consisting of 0. All real numbers except for 0. Right, then it asks for the vertical and horizontal asymptotes. So right here is an asymptote. Right here is an asymptote. Now remember, vertical lines have the equation x equals something. Horizontal lines have the equation y equals something. So vertical asymptote, we'll abbreviate with VA. So VA stands for vertical asymptote. X equals -1. Okay, and horizontal asymptote, I'll abbreviate HA. Well, it's the x-axis. X-axis has the equation y equals 0. Okay. All right, so reminder again, x equals any constant is vertical. X equals 4, x equals -8. Y equals any constant, y equals a constant is horizontal. Okay, so if it asks for horizontal and vertical asymptotes, you set this up. So if you know you have a horizontal asymptote, automatically it's y equals blah, blah, blah. If it's a vertical asymptote, automatically it's x equals blah, blah, blah. Okay. All right, here's number 5. Looks like this. All right, so domain. See if I can move this over without my book falling off the table. Okay, so domain, set of x values. Well, there's nothing out here, and it doesn't touch 1. It goes as far to the left as you want. So the domain is parenthesis, -infinity, 1 parenthesis, which means all the numbers less than 1, not including 1, everything over there. Okay. The range is all real numbers. You can go as high or as low as you want. All right, so it doesn't look like there's any horizontal asymptote. There is a vertical asymptote, and it looks like x equals 1. So a VA, vertical asymptote, x equals 1. Okay. All right, now 7 is a little bit weird. It's kind of complicated. But here's a function, x plus 1, x minus 1 over x minus 2, x plus 2. Okay. Now, what's all this symbol here? See, the arrow means approaches. Arrow means approaches. A minus and a plus means you're coming from the left or from the right. Okay, so let me put that down. So x arrow A is x approaches A. And then they will give a superscript, a writing above. If it's a minus or a plus, it means coming from the left or coming from the right. Okay, so x approaches A with a minus sign means x approaches A from the left. Okay. X approaches A from the left. It doesn't have to be a negative number. It just means coming from this side. And then X arrow A, if they superscript, put a number above with a plus, it means X approaches A from the right. So ditto, 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 ditto. In case you don't know, the ditto marks means just copy what was above it. This says X approaches A coming from the right. So it doesn't necessarily mean a positive number. It means you're coming this way. Okay, so you're approaching from the left. You're approaching from the right. If they don't give you a symbol like this, it means both ways, both directions. That's a concept you'll learn a lot more in calculus. Okay, so we're just making a sign chart here. Okay, now what's going to happen for 1, 2, 3, 4? These 4. Okay, you're going to have a vertical asymptote. Okay, so you're either going to go to infinity or negative infinity. So right away, the first 1, 2, 3, 4, it's either going to be infinity or negative infinity. Okay, stop and think about the vertical asymptotes. Here you approach negative infinity, right? On this side, you approach negative infinity. On this side, positive infinity, right? Positive infinity, negative infinity, negative infinity, positive infinity. So whenever you have a vertical asymptote, you're either going to go to infinity or negative infinity. Okay, vertical asymptote, negative infinity, positive infinity, positive infinity, negative. There's always something involving infinity. Okay. So automatically for these 1, 2, 3, 4, it's going to be either infinity or negative infinity. Then all you have to do is determine the sign, S-I-G-N. So see how they have these little parentheses here? That's supposed to be a sign chart. Okay, so I'm not sure if I can show you both at the same time. I know a little bit. Okay, so these are the signs that you get when you plug in here, 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 and here. Yeah, I think this works. Okay, you don't really need to see this. Let me cover this up. Okay, these 1, 2, 3, 4 correspond to these here. Okay. So this means a little bit to the left of negative 2. A little bit to the left of negative 2, negative 2.001. A little bit to the right of negative 2, negative 1.999. By the way, notice that plus doesn't mean it's a positive number. On the number line, if you move just a little bit to the left of negative 2, it'd be like that. The third one, the 2 minus, means a little bit to the left of positive 2, 1.999. This means a little bit to the right of positive 2, 2.001. X approaches negative infinity. You're plugging in a big number. So that's negative 1,000. And X approaches positive infinity, 1,000. Yes, there's numbers that are bigger than 1,000, a million, a billion, or whatever. Okay. So I'll talk about these later. Both of these are 1 in case you want to know. Okay, for these, we just have the sign. All right, so right away, I know these 1, 2, 3, 4, because we're going to have vertical asymptotes. It's automatically going to be either infinity or negative infinity. I just make a sign chart. So these 4 things that they have here, 2 on top and 2 on the bottom, right? Same for this, 2 on top, 2 in the bottom, 2 on top, 2 in the bottom. That's these 2 on top, 2 in the bottom. I just plug in. Okay, if I plug in negative 2.001 plus 1, that's a negative. Negative 2.001 minus 1, that's still a negative number. Negative 2.001 minus 2, that's a negative. Okay, negative 2.001 plus 2. They're really close, but that's a negative. Negative 0.001, it's negative. Okay, and the key thing is, this one is a real small number. So again, if you divide by a small number, you get a big number. Okay, so you have 4 negatives. 4 negatives makes a positive, so f of x approaches positive infinity. So that's the game we're playing. Negative 1.999, same thing. Plug in negative 1.999, add 1, negative. Negative 1.999 minus 1, that's negative. Negative 1.999 minus 2, that's still negative. But look at that last one. Negative 1.999 plus 2. That's a very small positive. And that's what makes this thing go to infinity. You're dividing by a small number. Remember, when you divide by a small number, you get a big number. So I have 3 negatives. 3 negatives leaves me with a negative. So f of x approaches negative infinity. Okay. All right. I admit it's harder when you plug in the negatives. We're more comfortable with positives. Okay, so x approaches 2. The minus sign means x approaches 2 from the left. X approaches a from the left. So a little bit smaller than 2 would be 1.999. Okay, 1.999 plus 1, positive. 1.999 minus 1, positive. 1.999 minus 2, that is negative, and it's a small negative. 1.999 plus 2, positive. So you have 1 negative. 1 negative means the whole thing is negative. So f of x approaches negative infinity. Okay. Then 2.001, it looks like they're all positive. 2.001 plus 1, positive. 2.001 minus 1, positive. 2.001 minus 2, a very small positive. So that's where you divide it by a small positive. It makes the whole number big, positive. And 2.001 plus 2, positive. Everything's positive, so f of x approaches positive infinity. Okay, now how about these? Negative 1,000. See, the thing about plugging in negative 1,000, that negative 1,000 is so big compared to plus 1, minus 1, minus 2, plus 2. You know the sign is going to be negative, right? Negative 1,000 plus 1 is negative. Negative 1,000 minus 1 is negative. Negative 1,000 is so much bigger in magnitude compared to 1 and 2, it's going to be negative. These are 4 negatives, right? When you plug in negative 1,000, there, I'm going to have 4 negatives. 4 negatives makes a positive. Okay. Likewise, plug in positive 1,000, positive, 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 okay, positive. Okay. Now how about this? Both of these f of x approaches 1. Okay, well, the thing I'm trying to get at is that if I plug in, let's do 1,000 first. If I plug in 1,000, 1,001, it's basically 1,000, right? 1,000 minus 1 is basically 1,000. 1,000 minus 2, 1,000 plus 2, it's basically still 1,000. It's really the same number divided by the same number. So I'm going to end up with 1. Okay, approximately 1. Not exactly 1, but approximately 1. I mean, if you want to get exact, this is 1,001 times 999. Right? If you had to estimate, you would say, okay, it's 1,000 times 1,000. Okay, this would be what, 998 times 1,002? If you were to estimate, you would still say it's basically 1,000 divided by 1,000. So the ratio is essentially 1. Same thing for negative 1,000. If I plug in negative 1,000 here, 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 and here, that would be what? Negative 999 times negative 1,001, which is positive. It's still basically 1,000 times 1,000. Same thing here. That would be negative 1,002 times negative 998. It's basically negative 1,000 times negative 1,000. That's it. It's essentially 1. Okay, so that's what we're trying to see over there. Number 7. Okay, then a couple problems here, and then maybe that's about it. All right, find the domain, the intercepts, vertical and horizontal asymptotes. Okay, so f of x is x minus 3 over x plus 1. Okay, so domain. Where is there trouble? The denominator, x cannot be negative 1. That's it. So the domain is all real numbers minus a set consisting of negative 1. Okay, intercept means you plug in 0. Okay, so plug in x is 0, figure out the y. Again, I say y, where's y? Remember, y is equal to f of x. You can always stick it in. So plug in 0. Put a 0 there and a 0 there. Well, 0 means it's nothing. So I can basically cover these up, right? Negative 3 divided by 1. So 0 comma negative 3. Right? Negative 3 divided by 1. And plug in y equals 0. So put a 0 here. Okay. I have a fraction equaling 0. When is a fraction equal to 0? So time out. When is a fraction equal to 0? When the top is 0. And b should not be 0. Right? If you have a fraction equaling 0, the top is 0. Okay? So what makes the top 0? 3. All right, so my intercepts are 0, negative 3, and 3, 0. All right, then the asymptotes, vertical asymptote, we already said that what is not allowed, x equals negative 1. Okay? Which means if I plug in a number real close to negative 1, it'll shoot either to positive infinity or negative infinity. Okay? And so the logic is if I plug in negative 0.999999, right, this becomes a very small positive, and whenever you divide by a small number, you get a big number. Okay. Horizontal asymptote. Okay, so again, the same concept. If you plug in a super big number, a million minus 3 is basically a million. A million and 1 is basically a million. Okay, so it's a million divided by a million, which is 1. So horizontal asymptote, y equals 1. Now, if you want an algorithm, it's basically, if you look at the first term, you can just kind of forget about the rest and pretend it's x divided by x, which is 1. Okay. Maybe by analogy, suppose you're a billionaire, a billion. If you're a billionaire, you're not going to sweat too much if you lose $3 or if you gain $1. You basically still have a billion, right? If I say a billion minus 3, it's a billion, right? A billion plus 1, it's a billion. So if you divide them, it's essentially 1. Okay, that's sort of the game that you're playing here. So horizontal asymptote, y equals 1. All right. Okay, then 15. Okay, so they give you something more tricky, and I have to do some factoring for that. So x cubed minus 2x squared minus x plus 2 all over x squared. Okay. So first I need to factor that, but I am noticing that if I plug in 1, I get 0. 1 minus 2 minus 1 plus 2 is 0. Okay, so I did polynomial synthetic division. Okay, remember synthetic division, right? 1, and then the coefficient, 1, negative 2, negative 1, 2. So this means the units, that means x, that means x squared, that means x cubed. We already know that, right? So it's a good practice for synthetic division. Okay, 1 comes down, multiply, add, multiply, add, multiply, add. So multiply, 1 times 1, 1. Add, negative 2 plus 1 is negative 1. Multiply, 1 times negative 1, negative 1. Add, negative 1 and negative 1 make negative 2. Multiply, 1 times negative 2 is negative 2. Add 0. Okay, 1 here means x minus 1 is a factor. Then how do you read this off? Numbers, x, x squared. X squared minus x minus 2. So the numerator, this x cubed minus 2x squared minus x plus 2 stuff, factors into x minus 1 Remember, if you plug in 1 and the remainder is 0, that means x minus 1 is the factor. X squared minus x minus 2. And now that just looks like algebra 1 stuff. Okay, so leave that one alone. How do you get 2, 1, and 2? You want to end it with a negative. So the negative should go with the 2 and the positive with the 1. You can double check with FOIL. All right. X times x is x squared. Minus 2x plus 1x is negative x. And then minus 2. All right. So I factored the numerator into all of this. And of course, I don't have any cancellation. That's fine. Okay, so let's look again at the direction. Okay, domain, intercept, asymptote. Okay, domain. What's not allowed? 0. So all real numbers minus 0. Intercept. X equals 0, you can't. So there's no y-intercept because x equals 0 is a known number. Y equals 0, got 3 of them. So remember, pretend this is y. So again, you have a fraction equaling 0. If a fraction equals 0, the numerator is 0, the top. So just ignore the bottom. What makes this 0? What makes this 0? What makes this 0? What makes this 0? 1. What makes this 0? Negative 1. What makes this 0? 2. Okay, so your x-intercepts are 1, 0, negative 1, 0, 2, 0. X-intercept, y-intercept. Okay, asymptotes. Vertical asymptote. Well, we already know x cannot be 0. So the line x equals 0, the vertical line, is an asymptote. Remember, when I write that, that's an entire line. It's the same as the y-axis. Horizontal asymptote. Now, I say none, but let's see why. Back in the original, this is 3rd degree, this is 2nd degree. Okay? When x gets really, really, really big, it's almost like you can forget about these. This will dominate. Like if I plug in a billion cubed is way bigger than any of these. So you may as well just pretend it's like this. So it's x cubed divided by x squared. What is x cubed divided by x squared? X. So I don't approach any number. And so I do not have any horizontal asymptote. Now we will learn later, this is going to be a slant asymptote. It's actually going to be y equals x. Okay, so y equals x will be a slant asymptote. I take it back, it's going to be x minus 2. But in any event, don't worry about that right now. This is going to be a slanted asymptote. Whenever the degree of the numerator is exactly 1 more than the degree of the denominator, we're going to have a slant asymptote. Okay, and show you that a little bit more in the text on slant asymptote, page 164. Okay, here's a slant asymptote. To determine the equation of a slant asymptote, suppose you have one of these. It's called a rational function, there's a fraction. The degree of the polynomial p of x is exactly 1 greater than the degree of the polynomial q of x. Okay? So that's when you have a slant asymptote. So this is higher by 1 degree. Then you have a slant asymptote. Sometimes you hear oblique asymptote. So this is degree 3, this is degree 2, slant asymptote. Or maybe this is 2 and this is 1. Or this is 5 and this is 4. Then you'll have something that's called a slant asymptote. Okay, but we'll worry about that later when we get to it. All right, folks, I'm done. Okay, so we're going to start the quiz. We have about halfway through. All right, so get your cameras out to take a picture of the quiz. All right, we're still being recorded. And then I'll put you into your breakout rooms. And when I put you in your breakout rooms, you can decide among yourselves, you know, how much time you want to do it. And as usual, you have the weekend. If you want to finish it within the next hour, you can turn it in then. But if you want to submit it by the next class meeting next Monday, That's fine also. Okay, so take a picture of this. I'll read it also. All right, so number one, draw the graph of f of x equals x squared, x minus 1, x plus 2. So do the same analysis that we did in class. Show me everything. What are the intercepts? Does it go to infinity on this side or negative infinity? End behavior, where is it positive, where is it negative? Okay. And number two, divide the polynomial p of x cubed minus 3x squared plus 3x minus 1 divided by x minus 1. Now, I'll let you do this either by long division or synthetic division. Either way is fine, okay, as long as you get the right answer. Show me all your work. Okay, this one I need a graph, and show me the analysis. Now, some of you have a graphing calculator, so you could just type it in your calculator, gives you the answer. I'm not going to accept that. Okay, I need to see your complete analysis of it, right? So show me, how did you get to 0? How do you know the end behavior, right? It goes up or it goes down and whatnot. Okay, so f of x equals x squared times x minus 1, x plus 2. Then divide this by this, x cubed minus 3x squared plus 3x minus 1 divided by x minus 1. We're still recording, so worst case scenario, you never get this. It's on the recording, and it's due at the beginning of our next class meeting, so what, 9:10 a.m. on Monday morning, right? Okay, so I'll assume everybody has it by now on your cell phone, so I'll stop the share. Okay, I'll stop.